Hello there, my name is Gregory, and we're doing Quadratic Applications, Section 1.5 of College Algebra. This question says, a company is making or manufacturing cones that have a height of 8 inches and the circular surface area is 32 pi inches squared. What is the radius of the circle? So as usual, let's draw a picture. Here's our cone. And they tell us that the height of the cone is 8. And the height of a cone is directly straight down from the tip down to the base at a right angle. So that's 8. And they tell us that the surface area of the cone is 32 pi. And so that's inches squared, and this would be inches, because this is an area, so that's square inches, and this is just a height, so that would be regular old inches. So it says, what is the radius of the circle? Or in other words, what is this length right here? And when I look at this, I see that immediately there's extra information that we don't care about. In fact, we don't even need to know that it's a cone, because it's just saying we've got this surface area, and we need to know what the radius is of the circle. So the formula for the area of a circle is pi r squared, and we know that the radius, the area of this circle, is 32 pi square inches. So we have pi r squared equals 32 pi, and we just solve that for r, and we're done. So you don't even need to know that this is a cone in this case. It's easier than that. So to solve this equation, first let's divide both sides by pi, which cancels them. So I get r squared is equal to 32. And to go from r squared to r, we just take the square root of both sides. So r is equal to the positive and negative square root of 32. Let's just see what that is. 32, hit the square root button. So let's do 5.657. R equals positive 5.657. R equals negative 5.657. Now, because this is a geometry problem, we can ignore the negative answer. And so the radius of the circle is 5.657. And we didn't even need to use the fact that it was a cone. That's just extra information. Next one, I know this is a little hard to read, so you might just have to use your own paper for this one. It says, I'm not going to read all of this, but basically we've got this ladder hanging against the wall, and it's kind of being propped up by this little wall right here. And the goal of the problem is to find the length of the ladder. So whenever you see a problem like this that has a right triangle in it, you should immediately think Pythagorean Theorem, which says that if we have a right triangle, a squared plus b squared is equal to c squared, where c is the hypotenuse of the triangle. And so if I've got this, they've got all of these crazy numbers here, but if you look, I would just break this down into one big triangle, where the entire base of the triangle is this 9 plus 2, which is 11. That's this whole length here. And this whole length here is 9 plus 4. That number's 4 right there. So this entire length is 13. So we've got a right angle right here. My hypotenuse is the unknown, which is L. So I have A, B, and C, and then we can just solve that. So we have a squared plus b squared equals c squared, or 11 squared plus 13 squared is equal to L squared. Make sure you put L in for the C value because that's the hypotenuse since it's across from the right angle. So let's do that. 11 squared is 121. 13 squared is 169. And then you can add like terms. Let's do 121 plus 169. And we get 290. And then just take the square roots of both sides. So L is equal to the positive and negative square root of 290. Let's see what that is. It's approximately 17.03. So L equals positive 17.03, L equals negative 17.03. And again, because this is a real-life application, we'll discard the negative answer. So the length of that ladder is about 17.03 feet. So again, don't overcomplicate these if you don't have to. I just added these to get the total base of the triangle, added these two heights to get the total height, and then just did a squared plus b squared equals c squared. which means we only have one more problem to go in this section. And so here we go. It says, this is a really important problem that we'll look at in more detail in class, but I'll just cover the basics on how to solve this right now. It says a projectile is launched from ground level with an initial velocity of v0 feet per second. So there's that value right there. Neglecting air resistance, its height in feet after launch is given by this formula. And so let's do this one part at a time. Find the time that the projectile will reach a height of 192. So our formula is S, which represents height, is equal to negative 16 t squared plus the initial velocity times t. That's the formula they've given us, which is the gravity formula in feet. And they've told us that the original velocity was 128. So this is vertical height. If you throw something in the air, only looking at how vertical it is, the height of it, which is s, can be given based on time. And they've told us this initial upward velocity. So it's going to be s equals negative 16t squared plus 128 feet per initial velocity. So I replaced VO with 128 because they tell us that's what it is. All right, so when will it reach a height of 192? Well, they're asking a question about time. When will something happen? And so I want to go ahead and put in 192 for this S value. Okay, plug in 192 for that value for S because we want to know at what time is it this height. And now you should know how to do this. We're just going to solve it. Move everything over. Now from here, you could go straight to quadratic formula if you would like, and that would work. Just plug in all the values. Be really careful when you're working it out with your calculator and order of operations. But I actually happen to notice that 16 goes into all three of these numbers, partly because I've done this problem already. But anyway, 16 will go into all of these. So let's divide every value by 16. And when we do that, we get negative t squared. Let's do 128 divided by 16, which is 8t, minus 192 divided by 16, which is 12. So we get this equation right here, which is easy to solve because it's factorable. Now it's difficult to factor these when the x squared, or in this case the t squared term, is negative. So let's multiply the entire equation by -1 just to flip all the signs to make this be positive. So -1 times 0 is 0. That sign flips, that sign flips, that sign flips. So now that's important. Now we have a positive t squared, so now we can solve this. So I need two numbers that multiply to make 12 positive that add up to -8. And those two numbers would be t minus 2 and t minus 6. So that's it factored, and so we actually get two answers to this problem. You'll notice that at 2 times will we reach that height, and so that should kind of make sense, because if we throw this object in the air, it is possible, like if our height of 192, say, is right here, it is possible that we would be at that height at 2 times. Because it would hit that height as it's going up and hit that height as it's coming down. So they're telling us that the first height was 2 and the second height is 6 is when we would hit that height of 192. Last part. They say, and again, if you did quadratic formula here, you should get these two answers. So if you don't, you did something wrong. Finally, it says, when is it going to hit the ground? When is the object going to hit the ground? So once again, our equation was s equals -16t squared plus the initial velocity, which is 128, times t. So we're going to hit the ground. What number do you think we plug in for s? Before we plugged in 192. This time we're going to plug in, that's right, we're going to plug in 0. Because if we're on the ground, then that means we have a height of 0. So we're going to solve this. And again, you could go straight to quadratic formula if you wanted to. In that case, c would be 0. But I'm going to do something a little bit more clever. Do you notice that we could factor out a t here? Always see if you can factor stuff out. And by the way, from the zero factor property, that means one answer to this is t equals 0. Does that make sense? Yes, because at the original time, the rocket or whatever was on the rocket was on the ground. So it makes sense that when we're on the ground, one of the answers is time is 0. And so to find the other answer, we use the zero factor property. Because this is 0 here, and because we're multiplying, one answer lives here, one answer lives here. So we just solve for this piece to find the other answer. So minus 128 minus 128. Negative 128 is equal to negative 16t, and divide both sides by negative 16. Let's do 128. Notice the signs are going to work out. So let's do 128 divided by 16. And we get an answer of 8. So t is equal to 8. So after 8 seconds, boom, at t equals 8, we hit the ground again. So there's a lot more going on with this problem, and I'm going to show you more about this in future lessons. But that's how you use quadratics to solve some basic applications. I'm sorry about this light. I'll keep trying to figure out how to make the light work better. Thanks for paying attention and for doing all of this, and I will see you in 1.6. See you then.